In this video, we're going to learn about errors that come up in hypothesis testing. So what we'll see in this section in this video and in some of your own reading that you might see in some other research articles is reference to types of errors that come up in certain statistical testing. So there are two main types of errors, and we'll look at them here together. So let's just recall that in a hypothesis test, we draw a conclusion about a population. And what were those possible conclusions? Well, in a hypothesis test, we have an initial hypothesis, our null hypothesis. And in the end, we can choose to either reject that H0, that null, or fail to reject. So that's a conclusion we can make. So then what happens if we make the wrong conclusion? That is, we reject H0 when in fact H0 is true. Or we fail to reject H0 when we should have, when H0 is false. So in either of these situations, what's happened? Well, we've made an error. So these two types of errors have different names, and we'll learn about them now. All right, so let's fill in this table together. So in this top row, I'm going to put in H0, my null hypothesis. So here are two different outcomes for my null hypothesis. The null hypothesis can be true or false. So we should think of this as what's happening in reality. So this is reality, what's actually true. And now we have two decisions we can make. So the two decisions are either rejecting H0 or failing to reject H0. So these are the two conclusions, our two conclusions we could make. Okay, so now let's fill in this table together. So in the occasion where the H0 is true, but we reject it, we've made an error. Again, just reflecting on that. So if H0 is true, but we say, no, we're going to reject, then there's inconsistency. So we say this is an error. In particular, this is what's called a type 1 error. Okay, so what are some other situations? Well, H0 could be false, so it's not true, and we reject it. Well, that would be a good scenario. No error is made there. Now let's continue. So H0 could be true, and we fail to reject it. So we don't say that it's false. So that's no error made. But let's look at the last scenario. So H0 is actually false, and we fail to reject it. So we've made an error. This is what's called a type 2 error. So let's summarize these two types of errors together in the box below. So a type 1 error is when we reject the null hypothesis. So our actual decision is to reject when it is true. So we reject the null hypothesis when it is true. This is often called a false positive. And in the next example, we'll see why that is the case. And then type 2 error is when we fail to reject the null hypothesis. Fail to reject the null hypothesis when it is actually false. This is often called a false positive. So maybe I'll give a little insight into this false positive or false negative. So typically, or often it is the case that the null hypothesis is a negative statement. So it's saying this does not happen. We'll see this in the example. And so then to reject it is saying, actually, it's happening, when in fact, if it's true, then that negative is really what's the case. So it's called a false positive. Again, we'll see this in the upcoming example. All right, so then we have some notation for probabilities of making these types of error. So we're not going to get into calculating these probabilities, but we'll look at the notation. So if you see this come up in some of your readings, you'll recognize where these symbols are coming from. So the probability of making a type 1 error is denoted alpha. So this symbol we've recently seen in our previous video on inferential statistics. Alpha is also the significance level of the hypothesis test. And this is no coincidence. So that significance level tells us the probability of time, or the probability rather, that our p-value will be so small that we reject the null hypothesis. So that will be exactly the probability of making that type 1 error, the probability of us rejecting. And then notation, the probability for a type 2 error is called beta. And we haven't learned how to compute that together, but often we use B, or Greek symbol beta, for that probability, or to represent that probability. All right, so let's put this into some context and look at some examples. So we have 2 examples that we're going to look at together. So in each of these examples, we're given a situation that's including a null hypothesis, and then we're given the possible outcomes of the situation, and we're asked to identify the types of errors. So let's say the null hypothesis is you do not have COVID. So this is the null hypothesis. So this is H0. Below are some scenarios of your sample. So you take a sample to determine if you do or do not have COVID. In this case, your sample is a result of the COVID test. So in part A, we want to determine which error or which statement represents a type 1 error, which statement in part B, which statement represents a type 2 error, and then finally in part C, which error has the greatest consequence. So first, let's go through these scenarios. So in the first scenario, we're told that your COVID test shows up as positive. So you get a positive result. And in fact, you do not have COVID. So here we've made an error. So this is not an accurate situation, or rather there is an error that's taken place here because the test that we've taken, the sample that we take, does not align with reality. Okay, so there is an error. We'll identify it in a little bit. Second situation, your COVID test shows up as positive, and in fact, you do have COVID. So here, though that really sucks, there's no error that was made. So this is a no error situation. The next situation, your COVID test shows up negative, and in fact, you do not have COVID. So no error here. And in fact, that's probably the situation we want to be in. All right, then what's happening in this last situation? Your COVID test shows up negative. So you get a negative result. And in fact, you do have COVID. You're actually positive. Uh-oh, an error has been made here. All right, so we see that these 2 situations are those that contain errors. So we can cross these out right away as situations where we have to consider what type of error is being made. So let's do that together. Let's consider which error is being made in each of these situations. So the fact is you do not have COVID. Our H0 is you do not have COVID. So the fact is H0 is true in this first scenario. But our test says that that claim, you do not have COVID, is false, or we reject it. So here we reject H0. So the type of error we are making here is a type 1 error. H0 is actually true, and we've rejected it. We say, uh-oh, nope, it's not true that you do not have COVID because my test is positive. All right, and then this last situation, your COVID test shows up as negative, and in fact, you do not have COVID. Oh, I misread that. You do have COVID. So here, 80 is false. Because keep in mind, 80 is you do not have COVID. So that is false. But you failed to reject that. Your test shows negative. So here you've made a type 2 error. All right, so here are the 2 errors that we could make, and here we're seeing them show up in the context. So notice here in this type 1 error, we are showing up as positive, but that is false. That's not actually what's true. We do not actually have COVID. So that's why we often call this situation a false positive. And in the second situation, we show up as negative, but really we don't have COVID. So this situation is often called a false negative. So then let's consider which error is the worst error. Well, in this first situation, your test shows up positive, but you really don't have COVID. So if your test shows up positive, maybe you're going to be more careful then. Maybe you'll isolate for a few days or some time, but you're not going to get sick because you don't actually have the flu. So that's not too bad. So in this situation, the false positive doesn't have a huge bad consequence. But let's look at the final situation. So in this case, your test shows up as negative, but you actually do have COVID. So here you might go about your business. You might have fun with friends and family. You might start to not feel good, and you might spread the flu. So this is a pretty bad situation. So we might say that the error with the greater consequence in this situation is our type 2 error. And often in medical situations, the type 2 error is worse, meaning having a false negative is worse than having a false positive. And you could think about why that might be. If we do get a negative test result, then our doctors might do some more tests. We can look further into it. We can maybe look into possible treatments or determine other tests that can really figure out what might be going on. But if we get a positive when that's false, then often no more tests will happen. So your symptoms might get worse or the issue might get worse. All right, let's look at example 2 now. So in this example, we're told that in a criminal court case, the null hypothesis is that the defendant is innocent. So I'm going to highlight that here. The defendant is innocent. So that's what we're assuming is H0. Now, the jury considers the evidence and they collect data, and then they make a conclusion about that defendant. And so they can make 2 conclusions. They can say guilty or not guilty. So which statement represents a type 1 error, type 2 error, and then we'll consider which is the greater consequence. So let's read these situations together and see which of them contain an error. First situation, a jury believes the defendant is guilty. And in fact, the defendant is innocent. So here we have some inconsistencies. So here we have made an error. Uh-oh. The next situation, the jury believes the defendant is guilty. And in fact, the defendant is not innocent. So if they're guilty, then they're not innocent. So here we have not made an error. So we actually want a check mark there. Yep, that's a good situation. The next situation, the jury believes that the defendant is not guilty. And in fact, the defendant is innocent. Well, yeah, if you're not guilty of the situation, then you're innocent. You shouldn't be charged for it, so there's no error there. And lastly, the jury believes that the defendant is not guilty. And in fact, the defendant is not innocent, meaning they should be guilty. So that is an error. So now I'd like you to pause the video and consider which of these two errors we've just identified is a type 1 or a type 2 error. And when you're ready, let's go ahead and think about it together. So here in this first situation, the fact is that the defendant is innocent. Well, the defendant being innocent, that is H0 being true. And we are rejecting it by saying the defendant is guilty. So this is a type 1 error. The second error, the fact is that the defendant is not innocent. So this would be H0 being actually false. But we claim that they're not guilty, meaning innocent. So here, this would be a type 2 error because H0 is actually false. So now consider which situation has the greater consequence. Well, in the first situation, we see that the defendant has been considered guilty by the jury, but really they're innocent. So in this situation, an innocent person is being charged for a crime that they did not commit. In this second situation, the jury found the defendant not guilty when in fact they're not innocent. So they actually did the crime, even though they were found to be not guilty. So this one is going to be a little bit up to you. In my opinion, I think the first situation is the worst situation. If an innocent person does crime, has to get paid, gets a fee for something they didn't do, that's very bad. In the last situation, the jury believes that the defendant is not guilty, and in fact, the defendant's not innocent. Well, then that means somebody who did something bad maybe gets away with it. I don't know. You might think that's worse. So maybe these are both bad situations. And I'll leave it to your judgment to determine which has the greater consequence. All right. So that concludes our discussion on the types of errors that we see in statistics and hypothesis testing. Thank you for watching.